Okay, hello everyone in a new video. So we have reached part 2 of chapter 7, which is the chapter of the voltage of the mains in the second unit of electricity. And eventually we have reached section number 5. And the title of this section is given by the fuse. Let me give the symbol of the fuse, then idea number 1. So this is the symbol of the fuse. It is identical to that of the resistor, but at the middle we have a wire. So what is the fuse? The fuse is an electric component that is used to protect other electric components from an overload current and against short circuits. Okay, now idea number 3 is that each fuse comes with a rated current Now suppose that this fuse, which is given by the fuse F, comes with the rated current which is given 0.5 amperes. Now we are used to the fact that a classical type of questions is given by or are given by what is the meaning of this indication. So let me write that the meaning of this indication is the rated current under which the fuse protects the circuit. And here let me highlight the main ideas. So this is the role of the fuse. So let me write here in blue that this is the role. And we know that this is important to memorize because we know that we may be asked about the meaning of this indication. Now moving to the to idea number 4, which is given by so now suppose, as we have mentioned previously, that this fuse have a current given by 0.5 amperes. So, and it's being traversed by the current I. As long as the current I is less or equal to 0.5 amperes, so nothing will happen to the circuit or especially to the fuse. If the current exceeds the value 0.5 amperes, suppose it's given by 0.7 amperes. So in this case, the rated current is the traverse current is greater than the traversed. So the traverse current is greater than the rated current. In this case, the fuse will cut off the circuit in a sense of, if the traverse current is greater than the rated current of the fuse, so in this case, let me say, of the fuse, then the fuse will melt, cut the circuit, which means now it is an open circuit, no more current is traversing the circuit, and protects other electric components and stops the current. So in this case, the fuse protects other electric components by stopping the current, whereas in the case of the resistor, it protects other electric components by limiting the flow of electric current. So the fuse stops, whereas the resistor limits the flow. Now idea number 5, let me say that the fuse, so also this is important, we need to memorize this. So okay, no need, because you know that this is important. So you should memorize this. Now, idea number 5 is that the fuse is of negligible resistance. And the voltage across it is 0. Then in this case, if we consider 2 points, say for example this is the point A and B, and you are asked about the voltage UAB, then UAB is equal to 0 because it is of negligible resistance. Now to the last idea, which is idea number 6. The most convenient fuse to protect an electric component is the one having rated current slightly greater than the traverse current. And let me give an example on this idea. Suppose here we have a fuse, or we need to protect a certain circuit. So this is a portion of the circuit, and the circuit is being traversed by a current I is equal to 0.5 amperes. And we have set of fuse that carries the following indications. Say for example 0.2 amperes 0.6 amperes and 0.9 amperes. Here they are telling me, so we have the following choices. These are the fuses, the indications of different fuses. So each of these represents a fuse. They are telling me the most convenient fuse to protect an electric component is the one having rated current slightly greater than the traverse current. So slightly means, or here you can, one can explain slightly greater, which means the closest. Now we need to protect this electric circuit traversed by the current I by a certain fuse. We have the following options. Then the most convenient one, 0.2 amperes, doesn't work because it is less than this. The fuse must have current greater than this. So we have 0.6 or 0.1, but the slightly greater is given by 0.6, which is the closest to 0.5 amperes. Okay, then this is it for idea number 6. Now let me move to the other section, which is an extra exercise that is not found in the notes as a direct application on the fuse. Now they are telling me document 1 shows an electric circuit consisting of a DC voltage source. So here let me say that UPN is 12 volts. A lamp L carrying the indication 0.5 amperes. Now notice that I didn't label this current on the circuit because we don't know yet if the lamp is functioning normally. We have the resistance R is equal to 8 ohms. The fuse F carrying the following indication 0.6 amperes. Now the circuit is said to be a closed circuit, and we have that the voltage UCD is given by 6 volts. Now in number 1 they are telling me what does the indication carried by L represent. L carries the following indication 0.5 amperes, and we know that this is the rated current. Of the lamp L, under which it functions normally. Now in number 2 they are asking me about the indication carried by F. So this is the indication of F. In this case F represents a fuse, and previously we have mentioned that the meaning of this indication is given by the rated current under which the fuse protects the circuit. Now as for number 3 they are telling me UAB is equal to 0. Notice that UAB is the voltage across the fuse, and we know that the fuse is of negligible resistance. Okay, so idea number 5 is that the fuse is of negligible resistance, which means the voltage across it is 0. The voltage So in this case UAB is equal to 0. Whenever they are asking me voltage across branches, then it means that we need to use the law of addition of voltages. Now in number 4 they are telling me to determine the voltage UBC. So indeed this can be determined using the law of addition of voltages. Let me make some space here. Then apply law of addition of voltages. So always on the left we'll place the voltage of the battery, which is given by UPN. And on the right hand side we write the voltages across different electric components, starting from P and ending with N. Each letter we will insert it twice, from P to A to B, B to C, making sure that UBC must appear, plus UCD, D to E, and E back to N, knowing that we are interested in determining UBC. So UPN is equal to 12, UPA is equal to 0 because across P and A we have a wire. So let me say that UPA. So here we have UPA, UDE and UEN, all of these are 0. Let me write them directly. And the reason is given by connecting wire. So plus 0 plus UBC. Now UAB is 0 because justified previously, plus 0 plus 0 plus 0. So in this case, here we have UCD is given by 6 plus 0 plus 0. So 12 is equal to UBC plus 6. So what's the type of this equation? Linear and one unknown. The unknown is given by UBC. Then UBC is equal to 12 minus 6, which is equal to 6. Now everything is expressed in SI, so the value of UBC will be expressed in SI, which is volts. Then UBC is equal to 6 volts. And let me label this voltage on the figure. Now in number 5 they are telling me to determine the value of I, calculate, and I can be calculated using Ohm's law because we know that we have the value of R and we know it's applied voltage. Then let's say apply Ohm's law to R. And Ohm's law is given by U is equal to R multiplied by I. Constructing the triangle of this formula, then I is equal to U divided by R. This is the voltage UBC across the resistor R. Then 6 divided by 8. And plugging this on the calculator, then the value is given by 0.75. Since everything is expressed in the SI, so the value of I will be in the SI, which is amperes. And let's label the traverse current on the electric circuit. So this is given by 0.75 amperes. Notice that this circuit only consists of one branch, which is a main branch, and the value of the current on all terminals is given by 0.75 amperes. Let me make some space. Now in number 6 they are telling me deduce that L may burn out. So the indication of the lamp is 0.5 amperes, whereas the traverse current is given by 0.75 amperes. Always in order to describe the functioning of the lamp, we need to compare the traverse current to the rated current. So let me say since the traverse current is greater than the rated current, of the lamp L, and between brackets let me say or specify that 0.75 amperes is greater than 0.6 amperes, then the lamp L, in this case it may burn out or function strongly. Since they specified it may burn out, let me say then it may burns out. Now in number 7 they are telling me in fact L doesn't burn out, justify. So whenever something is being protected from burning out, So we always need to think about the fuse. So notice that in this case, the indication of the fuse is given by 0.6 amperes. So now the traverse current, which is given by 0.5 amperes, will pass through the fuse, but the fuse is given by 0.6 amperes. Comparing the traverse current to the rated current of the fuse will open and protects the electric circuit. And this is mentioned here in this statement. So if the traverse current is greater than the rated current of the fuse, then the fuse will melt, cut the circuit, and protect other electric components and stops the current. Then let me say since the traverse current is greater than the rated current of the fuse, and in this case 0.75 amperes is greater than 0.6 amperes, then the fuse will melt, cut the circuit, which means open circuit, let me make space here, and protect other electric components, and this is given by the lamp, and protect the lamp L. Okay, so usually we are supposed to the fact that the lamp will burn out and the exercise ends at that point, but now in the presence of the fuse protects the burning of the lamp and it will cut the circuit. And now let's move to the other section, which is section number 6, the circuit breaker. Now previously we have the mentioned circuit breaker in this document, if you remember, in part 1. Now let's discuss what is a circuit breaker. Now this is the circuit breaker. Eventually there is no symbol for the circuit breaker, and let me start directly by idea number 1, which is given by the circuit breaker is a device that is used to prevent fire in domestic installations and protects them against overload currents. Okay, so this is the role of the circuit breaker. So first of all, it prevents fire and it opens the circuit in the case of overload currents. Now idea number 2, it is usually installed. So where do we use the circuit breaker? It is usually installed across the wires leaving the electric meter and entering our house. or entering the house. So we receive the voltage from the voltage of the mains, then it passes through the electric meter. We have seen previously what is the electric meter. It is the one responsible for calculating the electric bill, and we have calculated the electric bill. Now this is the circuit breaker. The circuit breaker usually it's installed after the electric meter. Now number 3, and we know that it is essential to install the circuit breaker because it prevents from fire and against overload currents. Now number 3, each circuit breaker comes with a rated current, and as we have said previously that there is a meaning for these indications. In the case of the fuse, we said that the meaning of this indication is the rated current under which the fuse protects the circuit. So here let me say the meaning of this indication is rated current. So in this case, this is the rated current which is here. This is 16 amperes. Rated current of the circuit breaker under which it protects the circuit. Okay, now as you can notice that this is similar to the fuse, but what's different between them, this we use it in the case of AC voltage, and the fuse we use it in the case of DC voltage. Now idea number 4, if the main current, now here we are not referring to the traverse current because we are talking about the voltage of the mains, we'll refer to the main current. If the main current is larger than the rated current of the circuit, and here of the circuit we means the domestic installation, so sorry, if the main current is larger than the rated current of the circuit breaker, yet we are not talking about the domestic installation, so then the circuit breaker opens the circuit and stops the current. Now idea number 5, to say that the most convenient circuit breaker for a certain domestic installation is the one having rated current slightly greater than the main current. So now what about ideas number 4 and 3? They are exactly similar to one of the fuse, but let's explain more. So we said that each circuit breaker comes with a rated current. So in this case, the rated current is given by 16 amperes. So this circuit breaker protects circuit under 16 amperes. Now, if the current is greater than 16 amperes, the circuit breaker will open. So in this example, suppose that the voltage of the mains deliver a current given by I is equal to 18 amperes, and the circuit breaker we are using is given by 16 amperes. This is indication, which means that this is the rated current under which the circuit breaker opens or protects the circuit. So 18 amperes main current greater than 16 amperes, so the circuit breaker opens. Now suppose that the current traversing the circuit is given by 15 amperes and we want to protect this domestic installation. Now, and we have circuit breakers of the following choices: 10 amperes, 16 amperes, or 20 amperes. Which one we choose? We choose 16 amperes because it's slightly greater than 15 amperes. This is it for the circuit breaker. Now we are done with the electric meter, circuit breaker. Now we are going to discuss the differential circuit breaker. Then idea number 7, the differential circuit breaker. Then idea number 1 is to say that the differential circuit breaker is a device that is used to prevent fire in domestic installation and protect people from electrocution. Now, electrocution is the process of or the injury due to electric shock, and this usually happens to human being when they touch a bare wire on or a wall outlet. Now, the differential circuit breaker is exactly the same as for the circuit breaker, so it is exactly the same, but the difference is that the differential circuit breaker is used to protect human being from electrocution. So this is the only main difference. And usually this differential circuit breaker is installed in our home and not in the building or outside the house, because it is easy for us to access the differential circuit breaker and turn it on and off whenever we want, and because it prevents from electrocution. Now let me write idea number 2, that it is usually installed across the wires leaving the circuit breaker entering our home. And idea number 3, that each differential circuit breaker comes with a rated current The meaning of this indication, as usual, the rated current of the differential circuit breaker under which it protects the circuit. So exactly the same. Now we reach idea number 4. If the main current is larger than the rated current of the differential circuit breaker, then the circuit breaker opens the circuit and stop the current. So exactly the same, no need to explain more. If there is any current leakage, now this is a new statement. If there is any current leakage, now at this level it's a bit difficult to explain what is meant by current leakage, but think about it as electrocution, which is the process of injury due to electric shock, determined by the differential circuit breaker So say for example this may be due to a fire or electrocution or for any reason. In this case, then the differential breaker opens the circuit and stops the current. Now as for idea number 6, which is related to the most convenient circuit, differential circuit breaker, for a certain domestic installation, is the one having rated current slightly greater than the main current. So basically the differential circuit breaker is exactly the same as the circuit breaker, but it is usually installed between the circuit breaker and the house, and the additional option compared to the circuit breaker, it protects people from electrocution. Now let me move to section 8, which is what causes the fire. And let me write down fire may happen in an electric circuit functioning under DC voltage if the positive pole positive and negative terminals are in direct contact. So what do we mean by this? In a simple electric circuit of a DC voltage source, fire may happen. Suppose here we have a resistor like this, and suppose that the resistor for some reason it is not functioning anymore, and it is being replaced by a connecting wire like this. So this is the positive pole and the negative pole, and there is nothing that separates the positive pole and the negative pole, so they are in direct contact. In order to avoid this, we use a fuse. Okay, so they are in direct contact. Now the fuse is a device used to protect against fire, or let me say not protect, used to prevent fire. Now idea number 2, fire may happen in an electric circuit functioning under an AC voltage if the live terminal and so let me say if the live and the neutral terminal are in direct contact. So it is exactly similar to the case of DC voltage, but in this case it is not protected by a fuse, but rather the circuit breaker and the differential circuit breaker are devices used to prevent fire. So fire can be prevented on an electric circuit using a fuse. So this is a summary in the case of DC voltage, and using the circuit breaker or the differential circuit breaker in the case of AC. Okay, so that's it. Now moving to the next section, which is the electrocution. And let me write the first idea. The human body is a conductor of electricity, so the body conducts electricity. A voltage above 25 volts in a damp place So by a damp place, we mean that the level of humidity is high, or of 50 volts. In a dry place, may send a current larger than 100 milliamperes in the human body. So in other words, the human body can be considered as a resistance. In case the applied voltage is given by 25 volts in some places or 50 volts in other places, then the transverse current, in this case according to Ohm's law, is given by 100 milliamperes. This current is sufficient to cause electrocution, which may lead in some cases to death. So if this lasts a few seconds, it would cause electrocution leading to death. Now, as for idea number 2, what this compared to the voltages that we have dealt with, the voltage delivered by a dry cell or a battery, which is a DC voltage source, is not dangerous since it is less than 25 volts. So it is less than 25, which means less than 50 and 25. And let me write here the voltage delivered by the outlet of the mains, which is given by 220 volts of an effective voltage, is dangerous, because in this case this amount of voltage is greater than 50 volts, 25 volts, and even 50 volts. Is dangerous since it is greater than 50 volts. Okay, so such type of voltages may cause electrocution because it's greater than 50 volts, which may lead to death, whereas the voltage of the batteries, most of them are less than 25 volts, that are not dangerous at all. And now we come to section number 10, which are the precautions that we can consider in order to avoid electrocution. So now in this case we know that this is a 3 terminals outlet, so one of them is the live, the other is the neutral and the ground, and we don't know which is which, so we can distinguish between them using a screwdriver tester. But in either case, one should not touch this outlet because electrocution may occur. Then the first precaution that we can consider is that never ever touch a socket or an outlet without releasing of the circuit breaker. So we never touch this outlet, and if you want to touch it for some reason, I don't know what is the reason. For example, if you want to fix something, then we should first release the circuit breaker or the differential circuit breaker installed in our homes. The second thing is that, now notice the wires are coaxial, made up of 2 layers. The outer layer is insulator, whereas the inner layer is the conductor, which is made usually of copper, Then never leave a bare wire connected to the live line or to the live terminal. Now suppose here in this case this is the live and this is connected here like this, and we touch with our finger this bare wire, then this may cause electrocution. Okay, so this is extremely dangerous. Now in order to distinguish also between these wires from the colors, so usually there is a conventional color for these wires, and let me write section number 11. Conventional colors of connecting wires. In most of the cases, when looking across the wall outlet, we cannot observe the color of these wires, but if we open this box we can observe the wires, and referring to the color of the wires we can notice that the red color for live, then in this case this is the live terminal. Idea number 2 is that the blue or black for neutral. So this is the black, it carries a black color, so this is the neutral. And finally, usually the green or yellow for the ground. Okay, and that's it for me in this video, guys. And by this we are done with the explanation. In the next part 3, we will start solving exercises on this chapter.